Air pollution contains carbon dioxide, CO2. For a sample containing 6.000 grams of CO2, determine 1. The number of moles of CO2, and 2. The number of molecules of CO2. And we're going to be focusing on the process, not the numbers for this problem, so ignore the significant figures. So this problem is all about unit conversion. We're given grams of CO2, and then we want to calculate the moles of CO2 from grams, and then we want to determine the number of molecules of CO2. So visually, we're going from grams to moles to molecules. Right? And like I said, this is all about unit conversion. So we're going from grams to moles and moles to molecules. So we're not going to be changing the value. We're going to have 6 grams of CO2 throughout the entire process, but that 6 grams is going to be represented by moles, and then that 6 grams is going to be represented by molecules. So it's really just a different way of expressing the 6 grams of CO2 throughout the whole process. And what these arrows represent is a unit conversion. And what do we need for unit conversion? We need a conversion factor. That's what these arrows represent. The use of a conversion factor to transform grams into moles and then moles into molecules. And we have 2 arrows. We have 2 unit conversions, so we need 2 conversion factors. We need one that relates grams and moles, and then one that relates moles and molecules. So let's get started on part 1. So we're given 6.000 grams of CO2, and we need to transform grams into moles. So we need a conversion factor that relates grams and moles, and that is the molar mass. So the molar mass is measured in grams over moles. So what's the molar mass of CO2? Well, we can look at the periodic table and then add up the atomic weights of the atoms, and that gets us the molecular weight of one CO2 molecule, and numerically the molecular weight is identical to the molar mass. So let's see, we have one carbon atom, which is 12 grams per mole, and we have 2 oxygen atoms at 16 grams per mole each. So we have 12 plus 16 plus 16, and that gives us a molar mass of 44 grams per mole for CO2. So this is now our conversion factor, the molar mass. It relates grams to moles. So to eliminate the grams of CO2, we divide the mass of the sample in grams by the molar mass, which is the same as multiplying by the inverse of the molar mass. So 44 grams CO2 in the denominator and 1 mole CO2 on top. That cancels out grams CO2, and we get 6 divided by 44, which is 0.14 moles of CO2. So now we figured out the number of moles of CO2 in a sample measured in grams. So now we want to go from moles to molecules. So part 2, moles to molecules. So again, we need a conversion factor, and the conversion factor is going to be Avogadro's number, which is 6.022 times 10 to the 23rd power. And Avogadro's number represents how many molecules are in 1 mole. So we could say that our conversion factor is 6.022 times 10 to the 23rd. This is the number of molecules per mole for a mole of any molecule. Here we have CO2. So that's 6.022 times 10 to the 23rd CO2 molecules in 1 mole of CO2. So the number of moles we calculated in part 1 was 0.14 moles of CO2. And let's use Avogadro's number as our conversion factor, and we want to eliminate moles of CO2, so we're going to multiply by 6.022 times 10 to the 23rd molecules CO2 over 1 mole of CO2. And look, moles of CO2 cancels out. And if we do 0.14 times Avogadro's number, that gives us 0.84 times 10 to the 23rd molecules CO2. But to be in proper scientific notation, we want this number in front of the 10 to the exponent to be between 1 and 10. So we move the decimal point over 1. So we have 8.4 times 10. So we increased this value by a factor of 10. So we want to decrease the exponent by 1. And our units are molecules CO2. So to review, we were given grams of CO2. We wanted to convert that to moles of CO2, and then molecules of CO2. To go from grams to moles, we need a conversion factor that relates the two, and that's the molar mass, which we can add up the weights of the individual atoms from the periodic table, and the molecular weight of a molecule is identical numerically to the molar mass. The units are just different. And we use that conversion factor to convert grams into moles of CO2. Then when we're going from moles to molecules, we use the conversion factor of Avogadro's number, which is 6.022 times 10 to the 23rd, the number of molecules in 1 mole of CO2. So we use that conversion factor to cancel out moles of CO2, and we're left with molecules of CO2. And then at the end, we just have to simply change where the decimal point is and the value of the exponent, and we get the number of molecules of CO2.